Today we're going to get started on a series, and it's all about the 3D Chameleon. Hello everyone, Chris here. The 3D Chameleon is a great way to add multi-material to your 3D printer. It's an add-on that should be pretty versatile and should work on just about any 3D printer out there. It's also very cost-effective. But with that versatility comes a few challenges, like being able to get your G-code processed correctly to use the Chameleon, as well as a few other things that you need to know to be able to use it effectively. So that's why we're going to jump into this series. Now, the Chameleon has evolved over the years. There's a couple of different versions, and I want to bring you up to speed to the newest version that's out there, show you how to build it, just in case you have an older model you might have had challenges with that you want to upgrade to the newest version, because this one is a lot more consistent and easier to use. So that's what this series is going to be all about. Today we're going to take a look at the Chameleon in general, we're going to build one, then we'll move on to things like tuning your G-code and just getting the whole thing set up so it works consistently. So let's jump right in, we'll take a look at the Chameleon, what you would get if you bought one, and then we'll move into building one ourselves. So here's a look at my 3D Chameleon. Now, remember, I printed my own parts. I had a Mark II version, and then I upgraded to this newest version. So the parts are different colored. It's going to look a little different than the one that you get if you order one. It's going to be all the same color, I'm sure, and it will be pre-assembled. But basically what we're doing here is we have some extruder gears that are driving the filament. There's two of them in there, back to back. And then we have a cam that slides this selector left or right to choose which filament that you want to print with. When the filament has been chosen, we're feeding it here through the bottom. We'll see how all this works here closer in a moment. We're feeding it through the bottom into this top tube, and then down to a Y pipe. The Y pipe allows you to use 4 different filament paths, and you can send it to one extruder. So you're feeding one down, using it, then pulling it back, and then loading the next one. So you can use one hot end for multiple materials. So the mechanism is actually pretty straightforward. You have some extruder gears, you can bring in the filament to the existing hot end, all that good stuff, but how do you actually utilize it during the print? Well, you have this controller board with a couple of stepper drivers on it. This is how it's powered, and then plugged in here is a trigger switch, and it's just a regular old end stop switch. But the way this works is you program your printer to go to a certain location wherever this switch is mounted, touch it for a certain amount of seconds, to select whichever filament you'd like to use. So 1 second, filament 1. 4 seconds, filament 4. There's a couple of other things you can do depending on how long you hold this switch, but you kind of get the gist. It's a very clever way to be able to utilize this on any printer just by swapping out some G-code commands. And when you purchase your kit, you're also going to get a handful of extra parts. I've had several of these kits over the years, different styles, different models, so all of my parts are kind of together, but you'll at least get some couplers, some tubes, some mounts, things like that that you can use to set up your Chameleon. So the Mark III version of the 3D Chameleon we're talking about here is very well thought out and pretty straightforward. It's a couple of extruder gears with a cam that enables you to select which filament or material you'd like to use, and based on the location of that switch, you can tell the G-code to go hit that switch for a certain amount of time to be able to select which one you'd like to use. And because of all that and the Y pipe that allows you to use multiple filaments on whichever 3D printer or hot end you'd like, I believe you can go all the way up to 16 different colors if you'd like to keep buying Chameleon units, just based on how you'd like to select them with that switch, which is pretty cool in itself. But I think the easiest way to understand how it works is to build one of these. So I'm going to show you how to go through the process of building the Mark III with the newer parts. All the parts are available over on Printables, some are in Tinkercad, but we're just going to go through all those steps. I'll show you how to assemble it, and this should help if you have an older version that you need to upgrade. So here's all the parts that it takes to actually build a 3D Chameleon unit. Now we're only going over this in case you have to upgrade it, but I think it makes it easier to understand how the whole thing works. So let's just go over the parts real quick. We'll start with the printed ones. These are what they call the Mark IV version of the parts, but basically you have the A parts, which are the outside, and then you have B and C parts, which make up the selectors. 2 of these, A and B, just one set, that's 2 colors. This set is another 2 colors. We have a couple of different printed spacers. You're going to get these with your kit. Based on how you mount this, you might need one of these. You'll definitely need one of these flat ones. You'll see more of that in a moment. We have our PTFE tube cutting guide. You'll see that again, but we actually put barbs on the PTFE tube to keep them locked in. That's what this will help us with. And then we have 8 of these bearing carriers. This is what the idler piece uses to slide back and forth. It traps one of these bearings to be able to grip the filament on whichever extruder you're using at that time. Again, it's going to make more sense in a bit. And then you have the 3D printed cam. This is what allows you to use these bearings to select whichever filament you'd like to use. It moves these carriers back and forth. You'll need 2 of these bearings for that cam. These are 10 by 19 by 5. You'll need 4 of these for the idler side of that filament gear. These are 16 by 5 by 5. You'll need 8 of these little springs. These are to spring load that idler, so it's easier to get the filament in and it'll always keep tension on it. These are 6 by 3.5 by 5. You'll need a couple of NEMA 17 stepper motors. These are basically the same motors that a lot of the companies use, like Creality. Pretty standard motor to have. And then some Mark 8 style or 8mm extruder gears. These are pretty common as well. And just some tips if you do have to 3D print these parts. Use the same printer and make sure all of the parts are in the same orientation. That just makes it easier to troubleshoot if there are tolerance issues. That way all of them will have the issue, not just one off and you're wondering why it doesn't work. They are very tight tolerance parts, they fit together very well, so your printer has to be pretty accurate. Also, you want to use 100% infill and use a 0.2 layer height, and I recommend PETG filament. That just gives you a little bit higher temp resistance, it has less issue to creep under load, and PETG tends to give you just a little bit more flexibility. PLA is a lot more rigid. So go with PETG. And one thing you're going to want to note on these parts right here, these bearing carriers, it has a number on it. This one says +2. This is the default part. And I haven't had any issues with them. They do work well. But you can print out different versions of these. There's different values in case you're having an issue with the filament being gripped by the extruder gear. Remember, these bearings set right here. The filament goes in between this bearing and this gear. These parts can be adjusted. There's different ones out there. They're available in Tinkercad. You can just print them out yourself. But you can use a different value to get you either closer to that extruder gear or further away, just to dial it in. So note, if you're having issues, there are different versions of this part out there. Everything will be in the description. So we'll start building. Both your motors are identical. Just pick whichever one you want to start with. One is going to have the extruder gears. The other is going to have the cam. Both of your extruder gears, remember these shafts are keyed. If you're using your own motors or you're swapping another one in, make sure that it does have a keyed shaft. They have to be kind of a specific value, but pretty much any NEMA 17 around a 40 is going to work. But at any rate, we're going to put our extruder gears on here. One is going to be way down on the bottom. I'll show you how to adjust these. And then the other one's just going to sit on top. This bottom one is actually so far down, it's going to be on the round part of the shaft, past the key. So when it's in the correct orientation, it's actually going to look something like that. Again, off the key side. So you'll be clamping this down to the round part of the shaft. And then the other one will set right on top. And as we build, I'll show you how to make sure these are in the right location. But we'll start there for now. And the other motor gets the cam. The slot on the cam, you can see both ends are a little different. The slot on the cam goes up. And there's also a flat spot that runs through the center for the key of that shaft. So the flat side needs to be lined up with that key, the flat spot on the shaft, so that it orientates correctly. It can be a little hard to get on, but if you can't get it on, if it's impossible, you probably don't have the flat spot lined up correct. But to start, one of these bearings will go on the cam. You want to push it up all the way as far as you can to this flat section, like that. And it's going to be a little loose until you put it on the motor, but then line up the flat side of the shaft with the cam, and you can slide it on. The cam will go all the way down as far as it can go on that motor. Just make sure it still spins freely. And then the other bearing will go on after we start to build. So for the printed parts, you'll have your spacer. This is a 2mm spacer. You want it to go on the extruder side, the one with the gears, because we're going to have to raise those parts up a bit to be able to line up with the teeth of those gears, just based on how it sets on the motor. The other side, you don't need one. Then we'll have our A printed part. Now, it is kind of important how these parts go together. You'll notice on the A part, we have the screw holes here. This one is inset a bit. That is so the screw is still long enough to make up for this spacer. So we want the inset screws on this side. Now, it only matters on the top portion where the screw head sets, but it's a good idea to keep the same orientation during the whole build. So we'll flip it over. We'll keep that letter A going the correct direction, going up towards the extruder gear, just like this. And then all of the other B and C parts will follow suit. We'll use the A+4 here to know which direction to put them in. The next one you'll want to put down is the C part. It has the oval in it, or like we like to call it, the racetrack. The other one has a cog in it, but it sets on it just like this around that bearing that has the cam. You can adjust that cam a bit to get it on there, but you can see that this part will slide left and right. The cam is actually what pushes it left and right. So that gives you an idea of how this is going to work. But we actually need to build this with the bearings before we put it together. I think it's actually easier to put the C and B parts together and then slide them on. You can do it whichever way. You can build it on the motors or on the side, but let's build one on the side so I can show you how it goes together. So again, we have our C part, and then we're going to have to put some bearings in here. So start by putting 2 of your springs in the part. There should be a little notch where the bottom of the spring sets. Just kind of set them in there for now. And then take one of your carriers and use it to compress those 2 springs up against that printed part. It'll just set in the housing, just like that. Be careful, those springs can get away, but that seat, it actually works better than you think it would. And then do the same for the other side. 2 springs, and then one of your carriers. And that allows for that bearing that's getting ready to go in there to be spring-loaded. Also, I printed all these in different colors just so it'd be easy to show you the difference in the parts. But, you know, orange and green, that's always good. And then you can load a couple of the bearings in here. The ones with the smaller internal diameter. And then another one of these carrier parts on top of that. And then your B part is going to go on top of this. Now remember the orientation of the letters. We have B and C here. Keep them the same. The difference here is this part actually has a little cog on it. So this is the part that the cam is going to hit to know when it's at home. So before you start a print, you'll run a home sequence. It'll go over here and touch. Then it knows where to start. You'll notice these parts over here with the little indentions. We're actually going to score the PTFE tube so it'll hold inside here. It actually works really well. But this is to enable you to feed the extruder or to load the Chameleon if you want to put PTFE in one side. You have to put it on the side with the Y adapter. We'll see that here in a second, but go ahead and build it. So this will go just right on top. And again, the parts fit really well. They should be nice and snug together. And then this whole thing can go back on the Chameleon unit. So again, we had our letter orientation. It goes C part down, just like that. So now the extruder gear that's on the bottom, that's the one that'll be utilized by this one to be able to select which filament you want to use. And now's a great time to show you how to line up that gear. So I'll just pull this part back off for a second. And what I like to do is just use this part, the center line right here, to judge where that extruder gear needs to be. So the middle of this part, that's where you want the filament to feed. So just set it on top of your A part right here on the side and judge where the teeth of that gear are based on the middle of this part. So you can see from the side here, you want the center of these teeth lined up with the center of these 2 parts. So mine actually needs to come down just a little bit. So we'll just adjust our grub screw. We'll make sure it's lined up nice in the center there, and then we'll tighten it back up. So that's a good way to tell, to make sure that these gears are lined up. You'll do the same thing with that top gear, but after you have this bottom one lined up, these gears and these parts are made in such a way that this one is going to set exactly on top of it, right up against it, and that will make it on the center of the part here on top as well. So after the first one's good, the top one should be good. And just so you can see it while we're here, I went ahead and threw this one together. But you can see how they're lined up. After the bottom one's lined up, the top one's good. So now that we know our extruder gear is good, make sure those are nice and snugged up. Remember that bottom one's on the smooth part of the shaft. So double, triple check that. That could give you a lot of issues. But again, our part goes right back on, just like this. Remember that cog is up. That's your B part. And you'll have an identical part, just like the one we just built, that goes on top of this for your two other colors. So our second part is built. It goes down right on top of that first one. And I think it's easier to go ahead and build this and set this on and then put your final cam bearing on after the fact. These cams are offset from one another, so it can be kind of tricky to get that on there, but it's much easier after it's assembled. So we'll just slide that on the top of that cam. Remember, make sure that cam's the right way. There should be the slot on the top of it. I just like to use a flat blade screwdriver to turn the cam if I need to move it a little bit to get it to fit better. But one of the biggest pro tips that I can give you is this bearing has a tendency to want to slide out, or if you have to adjust anything, you can lift this bearing with this printed part. You want to make sure that this bearing is fully seated on the back side of this cam. So I'll show you as I push it down here. Sometimes I'll actually get a larger socket, this is a 10mm, just to go down over this to make sure that I'm able to push that bearing down flush. You don't want to use too much force, but make sure that it's down there as good as it can be. Remember, it is a printed part. But when it's in the right place, it's going to be almost flush with the top part of that orange part there. So the C part. It still has to be up just a bit, maybe a millimeter, millimeter and a half to catch that cog, but you'll know when it's fully seated. That's what it looks like when it's correct. Then when those are on, you can put your other A part on. Again, keeping with the same theme, we've got the letter A there. But these parts here, where there's room for that screw head, they go on the extruder side. Remember, again, to compensate for that bottom spacer. So it goes on just like that. And then your Chameleon will come built, of course. So you'll have 8 M3 by 30mm screws. There'll also be 4 35mm M3 screws to mount it with these 4 center holes if you want to use one of those style mounts. We'll see that later on. But we'll take our 4 M3 by 30s on this side. And then for now, M3 by 30s on these 4 as well. And then we can work around and tighten these screws up little bit by little bit. Remember, these are printed parts. You don't want them too tight, but you want them tight enough to make sure the whole sandwich stays together. Because remember, these parts, these B and C parts, actually hold a PTFE tube on the side. So they have to stay clamped pretty tight for everything to stay lined up and working properly. But if you get them too tight, it'll bind and you won't be able to use it. So there we go, our assembly's looking good. All our parts are matched up. Just make sure the parts move freely left and right so that you can change your filament. And the assembly is pretty much complete. So as far as the mechanism goes, that's how everything goes together and all the parts that are involved. And remember, I'm only showing you how to build this in case you need to upgrade from an older version to the newest version. Even if you were to buy all of these parts and put your own together, you wouldn't have the controller board that you needed to control the whole thing. When you order this from 3D Chameleon, it's going to be completely assembled for you, so you don't have to worry about this. That's definitely the way to go. I'm just doing all this as part of the tutorial, so it's easier to understand how everything works. But we're not done yet. There's still quite a few things we need to do hardware-wise to get everything set up so you're ready to install it. So here we have our completed unit. We have our motor plugs here on one side or the other. It really doesn't matter. I believe by default when you get one of these are facing down, mine are facing up. But that's just in the orientation you want to install it in, if it's more convenient one way or the other. But there is a top and a bottom, and that's based on how it's going to feed, what direction it's going to feed the filament by default. So the top is this side right here. This is where the PTFE tubes will come out to feed your wide pipe and then go into your extruder. You will load the filament from the bottom. You can put PTFE tubes on both sides if you'd like to load them with it, but you have to put them on the top to get the force or that Bowden effect to be able to load that Y pipe. And you saw this before in the printed part. There's barbs inside here to hold that tube, but you have to score the tube for that to work. And that's the part we're going to talk about now. So the Chameleon will come like this, with your tubes already installed. They've already been cut the way they need to be able to be held inside here. But again, if you're upgrading, they have a jig here where you can score PTFE tubes to go inside these parts. The Chameleon also comes with a razor blade, and I think that's by far the easiest way to create these types of tubes. Again, this is the top of the unit. These are the tubes that feed the pipe that will feed your extruder. And I'm just going to show you on a short piece of PTFE I have here on how to cut one of these. But this is the jig. Again, you can download it. Your PTFE goes through this way. You want to put it all the way to the end there, just so you have a guide on how long the tube needs to be and where it is, based on what notches you're going to put in it. But turn it on its side, and then take your razor. I like to cut it straight down, just right up against the jig. Just push it down there good. It's going to make a small score. And then there's an angled section right here. Put your razor up against that flat. Be very careful. But then allow it to slice the pipe as well. And you're going to get a tiny little notch out of that tube. There should be 4 of them, but we'll move to this back one. Again, straight down. And then on the angle. And then we'll flip it over. Make sure you don't move, because these need to be equal. Make sure the PTFE doesn't move in the jig. We'll just flip it over. We'll do the same thing. Straight down, and then on an angle. And then the back one. And once you're happy with those barbs, then you'll just make a final cut straight down here in front. And then that will be the correct length for the tip of this tube to fit in the Chameleon part. You can see right there, there's barbs on either side. Your part also has those indentions on it, just like this, left and right. So we cut those in. Again, you can see them on either side, and it's going to go down into the part, just like that. And you'll feel it gripped twice. Now those barbs will keep it from being able to be pulled out of that part. It actually works really well. Now you could do it while you're assembling it. You could lay your tubes in here after you've cut them, put it all together, but I think it's way easier to do it after the fact. I haven't had any issues with doing this. They're a little hard to get in. They're almost impossible to get out though. That's a good thing. You can take it apart to get them out if you ever needed to. But this is a great solution, works really well. Just follow these simple rules. And go ahead and make all 4 of those on whatever tubes you're going to use to feed that Y pipe. And do it on the input side if you want to use PTFE over there as well. So back to this Chameleon, we'll go on from here and show you how this filament works. So we deal with 4 extruders here with the base Chameleon. We call them T0 through T3. It's just easier to call them that way because that's how you're going to deal with them in the G code. But this is T0, then you have T1 behind it, T2 up here in the front, and then T3 in the back. And then you're sliding the front one and the back one left and right with that cam to call whichever T0 through T3 that you might need. So you call that certain filament, there's T1, it brings it in from the bottom, loads it into the Y pipe. And it really doesn't matter where you load one of these PTFE tubes on your Y pipe, but I like to keep it organized because I think it's a lot easier to understand. So what I like to do is take the pipe that supports T0, the PTFE tube, and load it on this one here. The lower one, what I call on the left. Then T1 is the one behind that. I load it on the next one. The longer one there on the left. This pipe is the same front and back. Again, I'm just trying to keep it organized so I can show what we're going to do. And then T2 is the one in the front. I connect that one to the next one. and then T3 is the second lower one. I think doing it like this is just going to make it make more sense as I show you how to build code, as we install it, all those different things. So if you're following along, you might want to do this as well. Also, while you do this, you can see you put this in here. These are two-way couplers, just like any other Bowden coupler, but it's a through coupler. It's a little sloppy in there right now. What you want to do, hold that coupler, the top piece, with something flat, just kind of slide it under there, and push out on it while you're pushing that PTFE in. That way, it's going to bottom the PTFE tube out there in the Y pipe, and you won't have any of that slop up and down. So when you're trying to do retracts, something like that, you won't have any issues. Remember, that filament is going to be continuous all the way from the extruder down in here, all the way back to the Chameleon. Do that on all 4 of the PTFE sections. Make sure they're nice and snug, as well as the one that goes in the bottom to feed your extruder. Make sure it's nice and snug as well. This one here can be pretty much any length that you want it to be, but you're going to have to adjust that in the G code. We'll learn all about that later, but there are some spare pieces like this, some short sections in the Chameleon kit to hook it up. So there's the filament path. Then we have our motor wires, and I strongly suggest that you label your motors. I just call one of them 1 and the other one 2, and then I put the same lines on the wires. So here, the selector motor, I've labeled 1, and I've labeled the motor wire on both ends, and then the extruder motor, I've labeled 2. So we'll just plug them in on the motor side, and that way when you get to the board side, you'll know which one is the selector and which one's the extruder. And the board is labeled. So we have the extruder here, that's motor number 2, with the 2 lines on it, and then selector has the 1 line on it. That way you'll be absolutely sure you have them in the right orientation. And then you have your wires that hook up your micro switch to be able to select which filament that you need to load. You have wires for that. These are the trigger pins. The red wire will go to the inside of the board, the green wire to the outside. So the orientation is just like that. It does provide 5 volts to that micro switch. This is the micro switch side, and you can just plug it in. From here, you can go ahead and give it a test. In the kit, you get a 12-volt adapter. You can actually run these on 9 volts if you need to, but 12 volts is going to run a lot better. This is only 200 milliamp, so pretty much anything will run this board. You don't need a lot of current, but we'll just plug our power adapter in, and then we'll plug it into the wall. And when you get your Chameleon, it's going to come with the proper firmware. If you need to flash the new firmware, I have a whole video on how to do that. I'll leave a link in the description. It's pretty straightforward if you know what to do. But make sure you're on the correct firmware before we do the test. And then you can just test it by holding down your micro switch. And you should feel the motors start to tick. It puts a pulse out every half second so that you can tell what mode of operation or what it's getting ready to do. If you hold the switch down for 7 pulses, and then let go, that's going to home the extruder. That will get you home, ready to go into position 1. So we know it's moving correctly. If you hold the switch for 1 second, 1 pulse, that's going to get you loading extruder 1. You can see the extruder is turning. If you let it go, then you're going to be ready to select the next extruder. So we'll hold it down for 2 pulses. We've selected 2. When you hold the button now, it's going to back out 1. We actually selected 1 because we have to back it out. Then it's going to select 2 after you let it loose. Now we're on 2. It'll start moving the extruder forward to load 2. Now you're ready to select your next one. So we'll just go ahead and select 3. We'll hold it down for 3 pulses. So we've moved to 2 to be able to unload it. If we hold it down, it'll start unloading. Once you let up, we'll go to 3, then you can load 3. And same with 4. So we'll hold it down, 4 pulses. We're going to back out 3. Then we move to 4. start loading 4. And remember, I use this terminology, T0, 1, 2, 3, that's extruder 1, 2, 3, VOR. I'll try to keep it consistent. I still flip-flop back in between them, but no, that's what I'm talking about. It's going to be a lot more clear when we get to the firmware section. But that's pretty much it. Now you know everything about the Chameleon, how it's assembled, and how it's going to work going forward. And if you need to upgrade, you know all the parts and how they go together. So there you go. Everything you need to know about assembling the Mark III version of the 3D Chameleon. Remember, when you buy your Chameleon for $199 US, everything's going to come assembled. You don't have to do any of this stuff. But if you have an older version like the Mark II, this is the way you're going to get up to the newest version. And you definitely want to be on the newest version because you get to use that Mark III firmware. It works much better than the previous version in my opinion. Also, by assembling this, you know how everything's going to work going forward. I think it's a lot easier to understand how it's going to get the job done, and we have a lot more to do. We have to get it installed on our printer, find some mounts, mount that switch so that we can go to it and can control the Chameleon, as well as set up the G-code and the slicer that we're going to need to be able to do those multicolor prints. All that filament swapping, all that good stuff. But that will be for later videos. So hopefully you found this helpful. That's it for today, and I'll see you really soon on the next one.